Welcome back everyone. My name is Sagar and we are back here with another video. So this is the lecture number 23 of our Java and DSA course. And in our previous video we just learnt about strings, and we also faced the problem like when we were appending characters in our string, it was taking more and more space. So today in this particular video we will be solving that problem and we will just learn about string builders. So without making any further ado, let's get started. So in our very previous video, we were just solving that task number 22 where we have to input a string and after that we have to reverse and print it. So what was the problem there? So first of all, we are creating a scanner object and taking a string input, and after that we are creating a string object, new string object that is currently empty. So after that we were running a loop and we are just reversing from the back in our main string object, and after that we are just appending every character in our reverse string. So that is a very straightforward program, and let me just check here. So A, B, C, D, and you can see here it is showing me the right output. So what was the problem here? We saw the problem in our solution video, right? So when we are appending our characters in the string, so let me just show you. So this is our string we are creating. So suppose this is A, B, C, and when we are creating a reverse string, so first of all it will create an empty object here. So str is pointing to this and our reverse is currently pointing to this object. So when we are running a loop and we are getting every single character from our main string, so first of all we will get A and we will append reverse with A. So this will create a new string with the length of 1. So we will create A and our reverse will now point to this. And after that we will just repeat the same thing for our another two characters. So after that we will just write this AB and ABC. Sorry, we are traversing from the back, right? So here it is C, CB, CBA. So at last our reverse will point to this CBA. And you can see here there are multiple objects that we are creating and which have no use. So you can see these three arrays have no use now, and our garbage character will eventually wipe it out. But still you can see there is a lot of memory wastage here. So Java noticed this thing and they introduced string buffers to us. So what is a string buffer object? Let me just write it here. So before string builders we have string buffers, string buffer, and you can just use it. So new string buffer. So what is a string buffer object? String buffer is like a string, but it is more than a string. So first of all, the main property of string was it is using that string pool area to store its values, but a string buffer is directly storing values in the heap area. So what is the main difference between string and string buffers? String buffer uses dynamic arrays to allocate its object. So you can just control and left click here and you can see, yeah, string buffer is also thread safe. For now, just don't focus on what is multi-threading and what is thread safe. So you can see a thread safe mutable sequence of character. Mutable sequence, we know that strings are immutable, and here you can see string buffer are mutable sequence of characters. So it is like a string. As you can see, string buffer is like a string, so it works like a string, but you can see here the length and content of the sequence can be changed through certain some method calls. So if you watched our string video, you still have the same question: how can we change the size of our array? So what is string builder doing? So let me just show you. So this is our heap area, and after that there is some string pool area out there, string pool area. And when we are initializing a string object, suppose Sagar, so it will create a Sagar object in this string pool area. And after that when we are changing it, so suppose I am writing it here, so string s1 equal to Sagar. So first of all I am writing it as this. So there is a s1 object that is in the stack, and after that it is pointing here. So after that I will be changing this s1 equal to Java DSA. So this s1 will now point to Java DSA. So suppose there is this Java DSA and s1 will now point to this. But we already know that. So what is the string buffer doing? So when we are getting a string buffer object, you can see I'm writing it as, just follow this step, fb dot. So I'm using this capacity method of this string buffer class. So what is that? You can see here, return the current capacity. So you might be thinking that capacity is the size of our current object, but this string buffer object is currently empty. So it should return me 0. But let me just show you. So you can see. So you can see this thing. This is printing 16, but still you can see here the string buffer object is empty. Okay, I have to do this thing in our lecture 23. So let me just show you. So this is our heap area, and after that there is some string pool area out there, string pool area. And when we are initializing a string object, suppose Sagar, so it will create a Sagar object in this string pool area. So after that when we are changing it, so suppose I am writing it here, so string s1 equal to Sagar. So when we are getting a string buffer object, you can see I'm writing it as, just follow this step, fb dot. So why this is returning me 16? So let me just show you. So when we are creating a string buffer object using this constructor, we will just create an array of size 16. So 16 is just the default value. You can also pass any value here. So suppose I want to create an array of size 10. So you can see here capacity equal to 10 and it will just print me 10. So you can see here it is printing me 10, but when I am not passing any value, by default it will create an array of size 16. So this is an array of size 16 and initially this array will be empty, so there is no value in it, and we know it is a byte array, so all the values will be by default 0. When we are adding some characters in our buffer, so append, this append method will just add some particular characters that we are using here, so ABC. So it will just append it to the main buffer, like we have concat method in our strings. So s1 dot concat, you can see here ABC, and let me also print that string. So first of all, before appending, I will just print the capacity. So dot capacity method, and after appending, I will again print the capacity, and after that I will also print that buffer object dot to string. So this bf is an object of some particular class, so just remember that thing. You cannot just directly print any object using this sout method, like when we are writing it as this. So this is a string buffer object, that's why we can directly print it and it will just return us the string. But remember that thing, you cannot just directly print any object of some particular class, it will just show you some address. So as it is a string buffer, so we can directly use this, we don't need this toString method. So let me just print it now. So you can see here first we are printing Sagar, but you can see here this is Sagar and we are concatenating ABC and then we are printing S1. So it should print me Sagar ABC, but it is just printing me Sagar. And that is because of this concat method. So you can just control and left click, and you can see here it is returning me a string. So that means after concatenating it will return us a new object and we have to store that new object. So S1 equal to that new object. So when we were just writing s1 dot concat abc, so that means just we are writing 1 plus 2, but that doesn't make any sense. So we have to write it as s1 equal to s1 dot concat. So that means a equal to ab 1 plus 2. So that makes some sense now. So after that, let me just print again. So you can see here it is printing Sagar ABC, and after that you can see here first we are printing the initial capacity and that is 16, and after that after appending we are again printing the capacity, so it is still 16. But you can see now there are 3 characters in my string buffer object. So what is going on here? So let me just show you. So when we are creating a string buffer object, you can see when we are creating a string buffer object using its constructor, so it will by default create an array of size 16 and it is also a byte array, so that is why by default it will print me 16. And after when we are appending some characters in our string buffer, so what it will do, so it will just fill first 3 values, so abc. So abc will be here, and after that when we append more values, append def, so it will just fill next 3 values, so d e, okay, so c will be here, d e and f. So now there will be 6 characters and capacity will be still 16. So you can see here, there are 6 characters and still the capacity is 16. So that means by default we have array of size 16 and we can append 16 characters. But what if we are appending characters more than 16? So let me just write here a loop, and I will just write here a loop int I equal to 0. I should be less than 16. So we will just append 1 to 16, and after that we will again print the capacity, and before that let me just print here the string. So let me just run it. So you can see here, the initial capacity is 16 and we are appending characters from 1 to 16, so 1 to 15, sorry. So 0, 1, 2 up to 15, and after that the capacity is 34. So you can see I am not doing anything, I am just appending characters and I am printing the capacity, but you can see here the capacity is changed. So first the capacity was 16, and when I am appending character more than 16, so it will just increase the capacity. So that is the main thing. That is the concept of dynamic array. So it will just automatically increase the capacity of the array. So now what if I am appending characters more than 34? So I will just write here 34 and let us just check. So initially the capacity is by default 16. And now you can see after appending characters more than 34, you can see the capacity is now 70. So the main question is still the same. How can we increase the size of our array? So all the concept we learned till now, we know that the array are static and we cannot change the size of the array. And you can see first it is an array of size 16, and after appending characters more than 16, so it will just automatically increase the size. So what is going on here? So let me just show you how it is doing this. So first of all, we know the capacity is 16. Let me just clear this. So this is a capacity, this is an array of size 16, and when we are appending characters more than 16, so when this capacity is full, so what this string buffer object will do, it will just create another array of double size. So it will create another array of double size. So it is 16, so we will create array of size 32, and then what it will do, so it will just copy all the elements from this array to this array. So it will just paste all 16 elements here. So after copying all these elements, this bf, this object will now point to this array. So bf here. So you can also verify this whole thing by just control and left click on this append method. So why this append method? Because when we are adding some particular character, that will define whether we have to increase the size or we can just add that character in our defined size. So inside this append method, you can just control and left click and you will be here in this string buffer class, and you can see here super.append. So you don't have to focus on these things, what is super and what is all these things. Just only focus on our target. So append method is here, and after that you can see there is this another class abstract string builder, and you can see there is also append method, and after that you can see there is count and there is this space needed. So count, this current count plus size of this integer, we don't know what is that. So after that you can see here ensure capacity internal. So we will also check this. So you can see this is old capacity, and that is of, you can say, this value. So value is, you can see, byte array, and here you can also read the value is used for character storage, and we don't know what is this coder. We know that there is something that exists as old capacity, and then we are just doing some calculation, and you can see arrays dot copy of. So there is a copy of method in our arrays class, and we are using that, and after that we are defining a new capacity. So you can see here this value is equal to this thing. That means we are changing our array like we were doing in our string object. So suppose this is string pool area and we have this value. So our value will point to this, and after that, after we change some value, so we will create another array and this value will point to this. So we are just doing the same thing, value equal to some new array, and you can see here there is also a new capacity method. You can just read out this thing, and you can see here old length, new length, growth. So there are some factors here. So now that is a very cool thing. We are creating another array that have almost double size, and then we can append multiple characters here. And when this capacity is full, then we will create another array of double size, so that we can just use it without making any multiple copies like we were doing in our strings. So that thing is very clear now. But still there is a problem with our string buffer. It is slow. Yeah, you can also see here when we are creating a new array, we are copying all the elements and pasting it here. But that is not the only reason. They are slow because they are also thread safe. So you can see here when we were reading it, here you can see a thread safe mutable sequence of characters. So thread safe means it is safe to use when we are multi-threading. And what is multi-threading? So just for a very basic example, suppose I am doing a task with this hand and I am doing some different tasks with this hand. But using this both hands, suppose I am accessing this mouse. So when I am touching the mouse with my right hand, I cannot just interfere and touch it with my left hand. So there will be just a mess. They are not thread safe. But when they are thread safe, first I will move the mouse with my right hand and then with my left hand. So that is a very basic example. So the methods in the string buffer class are synchronized. So that is why they are a little slow. So when we are writing some simple programs like this, we don't need that multi-threading thing. So that will be a kind of overkill. Why we have these thread safe methods? They are not that much important, and they are also making our program slow. So what is the solution? So the solution is, you already know that, string builder class. So I will just comment all this and I will create string builder object. String builder sv equal to new string builder. So what is a string builder? String builder is the exact same thing as string buffer. They work the same, they have some same methods, and they both are also looking similar. So what is the difference between string buffer and string builder? So let me just control and left click, and you can also see here a mutable sequence of characters, while we can see in our string buffer you can see a thread safe mutable sequence of character, and that is the only difference. String buffer is thread safe, and that is why it is a little slow, and string builder are not thread safe, and that is why their operations, their methods are a little fast. So you can just read out all these things, a mutable sequence of characters, and this class is designed for use as a drop-in replacement for string buffer. So that is the only difference. Here you can see we were using StringBuffer in our single thread. So we just don't need that thread safe and synchronization thing. So we can just use StringBuilder object. So that is all about StringBuilder. This works exactly same as StringBuffer. It will just create an array of size 16. By default, it also have a capacity of 16, and also like StringBuffer, we can pass here capacity. So you can see here capacity equal to 10, and it also have same method append. Here we can append integers, characters, or any other thing. So suppose ABC, it is a string, and it also have same methods sb dot capacity, and we can also directly print this object sb. So it will just return me 16, because because by default the capacity in string builder is also 16. Okay, it is printing 10 here, and that is because we are passing here 10. So by default it have a capacity of 16. So you can see here it is returning me 16, and after that this ABC. So the capacity is by default 16 and the length will be 3. So the length means how many characters we have in our string builder object, and capacity means the total number of elements that we can have in that array. So there is a difference, right? And after that, let me just show you some more methods. So there is this equals method that should return us whether two string builder objects are equal or not. So let me just write here some example. String builder sb2 new string builder, and I will just write here same value abc. So you can see here sb1, so sb1, here sb2, and I will just write here whether sb1 is equal to sb2 or not. So what it should return, it will return me false, and let me check you and let me tell you why. So it is returning me false here, but why? You can see here this first object have ABC and this second object also have ABC. So it should return me true, but you can see here it is returning me false. So what is going on here? Let me just tell you. So first of all, at this line when we are creating a string builder object, so this SB1, it will create an array of size 16 which have A, B, C and then all other values. And after that, uh, at this line we will create another array SB2 of same size and same values A, B, C. So they are not same arrays. Okay. And after that, what we are checking is SB1 is equal to SB2 or not. So what is this equals method? So let me just control and left click. So you can see this equals method is not of this string builder class. It is of object class. But remember that thing when we were using this equals with our string objects. So suppose I'm writing another example here. So string a equal to abc, and string b equal to abc. So let me just use here, a string constructor so that you can just easily get the difference. So abc, so I'm creating a new string object using this constructor. So new string abc, so they will be also in our heap area, and there are two different objects. So in this example I am also doing the same thing. I am creating abc array which have three size abc. This is a, this is our string a, and here I am creating another string object which will have same values abc, which is b. So it is b, and when I have to check the equality of their values, so I will write a dot equals b. So it is returning me false and it is returning me true. So let me just show you. But what is the reason? When we are checking equality for our string builder object, it is showing me false. But when we are checking equality for our string object, it is showing me true. But when we are checking what is going in our memory, you can see here there is some sort of exact same thing going on. SB1 is pointing to this, SB2 is pointing to this, A is pointing to this, and B is pointing to this. So there are two different objects for our string and string builder also, and we have to just check the values in it. So why this is false and this is true? And that is because this equals method is not overloaded in our string builder class. I know you don't know what is overloading, and don't worry, we will just learn about that in our object oriented programming. But for now, just understand that this equals method is not of this string builder class, but this equals method is of string class. So you can just control and left click here, and you can see here there is the string class and we have some equals method. So that is the only difference. So I will just delete it. So when we are trying to call this equals method of our string builder, it is calling me object class method. So I will just control and left click. You can see here it is of object class, and that is because this string builder is a children of object class. Don't focus on these things. Just note the main difference, that this equals method is not of this string builder class, but this equals method is of this string class. So that simply means I can use equals method in this string, but I cannot use equals method with this string builder. So how can we check the equality in our string builder? So for this we have a toString method in our string builder. So toString. So let me just check here. So you can see here this toString is of string builder class, and I can just use the toString with both my string builder objects. So now it is not showing me warning, because now this whole thing is a string object and this whole thing is another string object, and then I can just use this equals method with my string objects. So now it should return me true, and you can see it is returning me true. So also one thing to remember, that when I am writing it as this, it will create some anonymous variable. So let me just show you. Let me just debug here. So first of all, I will create a sb1 object, and you can see there is this values array which have a size of 16, and after this line I am appending 3 characters. That means their ASCII value will be updated here. So you can see here on first index we have 97, that is the ASCII value of A, and after that 98 and 99, that is B and C. So after this line I will create another object, and you can see it is currently null, but it have a value that is a byte array which is of size 16. So when I'm initializing it, it still have a capacity of 16. So after this line I will fill 3 values, so 97, 98, 99. So you can see they have a kind of similar things here. And at this line, when we are checking sb1.toString is equal to sb2.toString or not. So after this line, it will return me, it will just print me true, and it will be at this line. So at this point, I am creating ABC. So first I am creating my A that have ABC, and next line I am creating B which also have ABC. And after that, I will directly check whether they have equal value or not. So it will return me true. And let me just show you more methods in my string builder. So sb dot, first I will remove all these things. So sb1 dot, you can see here append method and toString and compare to. So what is this compare to? Let us just check compare to, and I will just have this second object sb1 dot compare to sb2. So what it is returning? So this compare to is returning me an integer, and you can also read here compares to string builder instance lexicographically, and that means it will just compare the ASCII values, and this method follows the same rule of lexicographically comparison as defined here. So let me just check here what it will return. So it is returning me 0. 0 means true, and if it is not equal, so what it will return? It is returning me -1, and that means this second object have a greater size than this first object. So what if I am writing here D, and in my second object I only have 3 characters. So so now let me just check. This sb1 have a greater size this sb2. So now it is returning me 1. So that means when sb1 is equal to sb2, so it will return me 0, because both the string builder objects are equal. But when my first string builder object have a greater value than my second object, then it will return me 1. And after that, if sb1 have lesser value, lesser ASCII values, that means it is lexicographically smaller than sb2, then it will return me -1. -1 means that sb2 is greater, +1 means that sb1 is greater, and 0 means both are equal. So that is also a method that you can use to check whether they are equal or not. And now let me just check more methods. So append, toString, delete. So you can just insert some particular character at some particular index, and you can also delete, and you can also get this index of some particular character like we have in strings. And there is this reverse method that we used in our previous video, and there is this is empty, and you can just check all other methods in this. And now it is time for your practice problem. So today in your task 23, you have 2 questions to do. And in your first problem, you have to check whether a string is palindrome or not. So first of all, you have to take a string input, and suppose this ABA is our input. And then we have to tell whether it is palindrome or not. And if it is, then we will print yes or else no. So first of all, what is a palindrome? So palindrome means a string that we can read exact same from front and back. So when we are reading it from front, it is ABA. And when we are reading the string from back, it is also ABA. So another example, race car. So when we are reading it from front, so RACECAR, and when we are reading it from back, RACECAR. So it is a palindrome string, and we have to just print yes or no. So we have to check, and you have to write some algorithm how you can check from front and back. So after that, our second problem is whether we have to check whether two strings are anagrams or not. And suppose we will be given two strings, so ABC and then BCA. So we have to check whether they are anagrams or not. So two strings are said to be anagram of each other when they satisfy these two conditions. And the first one is they should have same length. So same length. And after that, second condition is they should have same frequency of all the characters. Same frequency. So what is the frequency of A in our string 1? That is 1. So A is one time in our first string, and you can see in our second string A is also one time. So A is one time. And what is the frequency of B in our first string? So B is one time in our first string. We can say the same thing for our second string. B is one time. And what is the frequency of, here it is one time. And what is the frequency of C in our first string? It is also 1. So let me just write here C 2 times. So frequency of C in our first string is 2. And suppose for an example, this second string is Z. So what is the frequency of C in our second string? So frequency of C in our second string is, you can see C is first time, C is second time. So frequency of C is 2. So they should have same frequency. A is one time, A is one time. B is one time, B is one time. C is two time. So if they satisfy these two conditions, then we can say they are anagram. And if they are anagram, then we have to print yes, else no. So you have to just solve these two problems, and the first one to comment the answer will get a huge shout out in the upcoming video. And we will also see the solution of both of these problems in our upcoming video. So that is it for today, everyone. If this video is helpful, go hit the like button and also subscribe to our channel. And thank you for watching.